Okay, completing the square is probably one of the more difficult concepts, so please watch this video over and over if you have to. Please try to understand it the best that you can. Now I'm going to go over a couple of different kinds of examples. There's easy ones and difficult ones. The easy ones are like this. I want to figure out what number do I put in here that would complete the square, meaning that this would be a perfect square trinomial. So if you remember the rule, it was x squared plus 2ab plus, a squared plus 2ab plus b squared. So really, we know that the a is x, so this goes with this right here. We need to figure out what b is. In other words, 2b equals 10. So I'm going to divide both sides by 2, and I'm going to get b equals 5. So it tells me to do b squared, which means the number that should be right here is 25. Hopefully that makes sense. Let me do another example. X squared plus 16x plus blank. This is a perfect square trinomial, so I need to figure out what number needs to go right here. 2ab is 16x, and we know that the a is the x, so that kind of just gets out of there. So that means 2b equals 16. I divide by 2, and I get b equals 8. So it has to be squared when it goes right here. 8 squared is 64. And that's what we're doing on the really simple ones. But many of them are much harder than that. So let's look at what happens when they tell me something like this. If it gives me a value already in there and it wants me to complete the square, I need to change stuff around. So what I need to do is I need to figure out what number do I use right here to complete this square. Because I want this to be in parentheses as x plus some number squared. So it's the same thing. I'm going to pretend that the negative 13 isn't there. And I'm just going to put it on the outside of whatever I get right here, okay? So I need to pretend that it's not there. So I do the same thing that I did before. 2b equals 10. b equals 5. So that means in order to get this to be a perfect square, I have to add to this equation 25, or 5 squared. So this number right here is going to be 5. And because I added 25, I have to add it right here as well, okay? Now I'm going to simplify x plus 5 squared plus 12. And that's the completed the square simplified version. So if you notice now, it's now in vertex form, so I can tell the vertex of this function rule. And that's why we're doing this, is kind of to find the vertex is one of the main reasons. The other reason is to solve. So this one is a function rule. We can't solve it, but on an equation we could, okay? Look at a slightly harder one. A slightly harder one is if I have something like this. And it asks me to solve. So I'm going to do the same thing. I'm going to do something slightly different because this has a number in front of it. So what I want to do is, the first thing I want to do is I want to trap my x's. So that's the first step. Trap the x's. The second step I want to do is I want to just get rid of an x from both of them. And I say drop one x. So I dropped an x from here, it became x instead of x squared. I dropped an x from here, it became 18 instead of 18x. The next thing I want to do is I want to factor out this a value. So it's going to go on the outside of parentheses. And I need to make sure that I divide both of these. So factor out a. The next thing that I need to do is I need to divide this by 2. The reason you divide by 2 is, remember that in that perfect square binomial, it's always 2ab in the middle. So the 2ab is what we're trying to get rid of right here. That's why we're dividing by 2. So now I'm going to simplify. and I'm going to square the term. If I expand this, it's not going to be the same as what I started with. This is going to give me 9 times x squared plus 2x plus 1. So this is different, which means that I've changed the equation. I'm going to distribute and see exactly what's different from my beginning equation to my final equation. You're not actually going to do this, but I'm just showing you. So what's different in the beginning one? Well, I had 9x squared, I had 18x, I had minus 3, but I didn't have this plus 9. So what I did is I've actually added plus 9 to this side, so I need to add plus 9 to this side. We're not going to do that. We're going to keep it right here. But if I wanted to show you why, that's why I did that. So what we did is, when we squared this, we added this number squared times this number. So I'm going to add to the other side, this number squared times this number, or h squared. Well, I'm not going to put it there. I'm going to put plus 9 right there. But I'm going to write add h squared. So h squared times a, that's where that plus 9 came from. Now I'm going to try to solve for x. So I'm going to get the x alone. So the first thing I'm going to do is that I'm going to add 3, which gives me 9x plus 1 squared equals 12. I'm going to divide by 9, which gives me x plus 1 squared equals, this is going to be 4 over 3. And now we're going to square root both sides. So I would square root both sides. And I'm getting x alone on all these steps, so I'm just going to write that. Square root each side gives me x plus 1 equals the square root of 4 over the square root of 3, or 2 over the square root of 3. I'm going to subtract 1, which gives me x equals negative 1 plus and minus 2 over the square root of 3. Whenever you have a square root, it should be plus and minus in front of it. Now you can't actually have a radical on the denominator, so I'm going to multiply this by a version of 1, which is the square root of 3 over the square root of 3. So it's going to be negative 1 plus or minus 2 square roots of 3 over 3. And that's the final answer. I know that it's complicated, but let me do another example, okay? So, whole matrix stuff there. So, first thing I do is I trap the x's. Then I drop an x from each. Then I factor out the a. Then I divide by 2. Then I square it. Then I see what this term squared times this is, and I add it to the other side. So 1 squared is 1 times 3 is 3. Now I'm going to try to get the variable alone, so I'm going to divide by 3. I'm going to square root both sides. And you square root the top and the bottom when you square root. I'm going to subtract 1. Which it seems like this is the exact same answer as the last one. We're going to simplify. And that's the final answer.